Okay, the square root of, that's Miriam. Please, just a minute. Did you send the question?
بس ثواني الحين قاعد يحمل عنده.
Okay, I'll start with my own questions till you send yours. Let's say that.
بعدت أنا خلاص.
Okay, let's say you have I to the power n. Okay, how you're going to solve this question? Let's say that n is equal to 6254, which was my midterm question. You will start by checking if this number is even or odd. Is it even or odd? It's even. So you'll go by this way. I square to the power 6254 over 2. Okay. I squared is actually equal to -1. And 6254 over 2 is someone just please turn off your mic, please.
3,121.
3,127, right? Now, by looking at this number, is it even or odd? Just look.
Odd.
It's an odd number. Then the answer is -1. Okay. This is how you solve I to power. Okay. If you have a different number, let's say I to 481, you will check, is it even or odd? It's an odd number. Then you'll take an I out, then you get an I square, and you will get here 480 plus 1. Okay. And you will divide it by 2, which is going to be 240. Now you will check, is this number even or odd? It's even. So I square, or which is also -1, will become just 1. 1 multiplied by I is just I. Check it with your calculator if you want to. That's for the I, if you're just using the I to the power n term. Some of you sent me a question which is len -1. Do you know how to solve this? I sent you the solution on WhatsApp. Do you guys hear me?
Yes.
Okay. Do you know how to solve this one? I don't think so. Okay. Z is equal to -1. Set this Z equal to -1 and change len to len Z. Now you need to find len Z. The first thing that you're going to do is change Z to the polar form. Okay, which is RE to the power I theta. Okay, we need to find R. R is just the magnitude of the imaginary and the real part of the equation. The real part is just number 1 squared, and the imaginary part is 0 squared. You will get 1. That's the magnitude, which is R. As for theta, you'll go by tan inverse. And you will write the imaginary and the real part. The real part goes in the denominator, which is -1, and the imaginary part goes in the denominator, which is 0. You will need to draw this diagram, the j omega axis and the real axis. You will check what's the real axis, is the real numbers. You'll set the real numbers, which is on -1. And as for the j omega axis, you don't have any real values, so you stay here in the real axis. And you will measure the angle, which is pi or 180, but you will go with radians, which is pi. So theta is equal to pi plus 2n pi. 2n pi is just a counter for you to count the revolutions. So maybe you want to count pi after 3 revolutions, you just substitute n with 3 and you'll get the number. Okay, so now just substitute these values back here. R is equal to 1 e to the power I. The theta is equal to pi plus 2n pi. Simplify it. You can simplify it using either the cosine and sine term or just keep it as it is. You can keep it as it is, it's much easier for you. Okay, it will come e to the power pi, 2n pi. If there's no any other values, if you're not using any powers, you can just cancel it, because 2n pi is basically 0. Okay, so you will have this term, -1 is equal to this term. Now you can just substitute it back here. Now you can just substitute it back here, which is ln e to the power I pi. Ln with an e get cancelled, you'll get I pi. So ln -1 is equal to I pi. Okay? Do you understand this?
Yes.
Okay, good. Okay, if I gave you ln -2, can you do it? Yes. Okay, only Mariam says yes. What about everybody else?
I think it's the same thing, right?
No. Almost the same, but not exactly. Not the same answer. I will leave it for you to solve it. If you didn't know how to solve it, you can contact me on WhatsApp. Okay, you have this thing is actually a bit tricky, which I had a problem with when I was taking analytical. When you have this term, x to the power n plus or minus 1 equal to 0, or is the same of x to the power n plus or minus 1, or any number in general. And there's this term, which is 1 plus or minus I to the power n. These two are very similar in solving matter, but they're not exactly the same. Two different strategies. So do you know how to differentiate between these two? Guys? No, okay. It's fine. I'll give you some examples and I'll show it to you. Let's say that you have x to the power 3 equals to -1, and you are required to change it to the polar form and find all the solutions of this formula, of this equation. The first thing is that you need to find r. Okay, r is equal imaginary and real part. The imaginary part is just 0, so 1 square plus 0 square is equal to 1. And as for the theta, you have tan inverse -1 and 0, which if you use this graph, you will get a pi, a full pi. So the answer is pi 2 and pi as for the angle. Now substitute it in it's in polar form. You get x to the power 3 equal to e to the power I pi plus 2 n pi. Now you cannot cancel 2n pi like the first equation because you have a power here and you want to get rid of the power because what you want is the answers of x, all the possible answers of x. So you will take a cube root, or I don't know what it's called, or you can just do the power thingy, this 1/3, which I prefer. And you'll get this x equal to e I pi over 3 plus 2/3 and pi. Okay, now you're halfway done. Now you need to change this one to the polar form, to its polar form. As you see here that we don't have an r here, which is going to be easier for you in solution. You have cosine, the angle here, pi over 3 plus 2/3 and pi, plus I sine pi over 3 plus 2/3 and pi. Clear so far? Guys?
Is this the final answer?
No. Okay, now we need to work on the n values. Let's say you have n equal to 0, x of 0 or x naught will be equal to cosine pi over 3, because n of 0 just cancel this term, plus I sine pi over 3. Okay, Dr. Al-Sha'bi will actually give you an equation sheet where these values are actually written. So you'll need to substitute these values using the equation sheet that Dr. Al-Sha'bi sent you. So just check the WhatsApp, which I think he gave it to me. Okay, cosine pi over 3. But we have sine pi over 3 and I need the cosine. Just a minute, please. Okay, cosine pi over 3 is equal to half plus sine pi over 3 is equal to 1 square root of 2 over square root of 2. This is the first answer. Now you'll have n is equal to 1. X of 1 will be equal to cosine pi over 3 plus 2n pi. The 2n, n is equal to 1, so you have only 2 pi plus I sine pi plus 2 pi over 3. Okay, now we need to simplify this more. You'll get cosine, this one 2 plus 1 is 3, 3 pi over 3 is just pi. So cosine pi plus I sine pi equal. Cosine pi is equal to what? -1. I sine pi is equal to 0. So this is the answer. This is the second answer. Now you'll go to n is equal to 2. So x of 2 cosine pi plus 2 times 2 pi, which is 4 pi over 3, plus I sine pi plus 4 pi over 3. Do you know how to use the table that Dr. Shabi sent you? It's not a table, actually, just given values. Cosine, simplify this. Pi plus 4 pi, which is what? Guys, talk to me. Hello.
5 pi.
5 pi over 3 plus I sine 5 pi over 3. Okay, now we need to search for the value given by the equation sheet. 5 pi over 3 is equal to half. So cosine 5 over 3 plus I, the sine 5 pi over 3 is just, I think, 0. Just
I
let me
think
make
it's 1
sure.
over square root of 2.
What?
Yeah, I think it's 0.
Just a minute, please. No, I think that you're right. Negative 1 over square root of 2, I think. Just a minute. I'm just checking for the value. I cannot see it. Five pi over 3. No, I want a sign. Okay, just find the value. I think the value is negative pi 1 over square root of 2. It must be like that. Now you find n equal 3, which is x of 3. You will solve it. You'll get cosine pi plus 3 times 2 is 6 pi over 3 plus I sine pi plus 6 pi over 3. Now we need to simplify it. 7 pi over 3 is equal to cosine pi plus 2 pi plus I sine pi plus 2 pi. Do you get how we get this from here? Do you understand how we got this from here?
Yes.
Okay. When you have a 2 pi or 2n pi at the end of the solution, you can just cancel it. Okay. Now go back and compare it to your first equation, and you will get this cosine pi over 3 sine pi over 3. So when you finally reach the point that you're repeating your answers, you know that you just finished the solution. So you'll have only 3 solutions. The first solution is x of 0. The second solution is x of 2. The third solution must be like the x of 0, but with a different sign, the conjugate of x of 0. Okay. How do you know how many times you need to do the n? Depending on the power. It's not always correct. Sometimes we'll give you like x to the power 8, and you only have to do it for only 4 times, and to equal 4, maybe. But at least for smaller numbers, you will use the number of the times that you will use n is the same number of the times. Sorry, the number of the n's is the same number of the power here given. Okay. Do you know how to solve this problem? Do you understand what I did here? Hello, guys. Hello, guys.
We wrote it in
Yes.
Okay. Now we have something similar, even similar in solution, but different in some cases or some stuff. Let's say you have 1 plus I to the power 4. How can you find this without using your calculator? You will need to have, first thing is R, the resultant vector, or call it whatever you want. Will become 1 squared plus 1 squared is equal to square root of 2. Now, as for theta, tan inverse 1 over 1. The factor of this and this one. The factor of the imaginary part and the real part. Use the diagram. You have a 1 here, 1 here. Connect them. You will see that you have a pi over 4. Okay, which is 45 degrees. Okay, so theta is basically pi over 4 plus 2 and pi. Do not forget the 2 and pi, please. Okay, now you need to substitute it in the form of r e I theta. The r is square root of 2, e I. The theta is pi over 4 plus 2 and pi. Change this to the cosine and sine form, which is the imaginary form. Square root of 2 cosine pi over 4 plus 2 and pi. Plus I sine pi over 4 plus 2 and pi. Okay. You will see that we don't have any power that we need to get rid of. How's that? What we got here, just let me do something else. Sorry. Just cancel this term. Sorry. Forgot about something. Sorry for that. Okay. This term is equal to I plus 1, which is this term. The inside the bracket, not the outside of the bracket. So what you need to do is just add the powers. So I to the power 4. Okay. Now you need to do it on everything inside the bracket. So the square root of 2, the power 4, e I 4 here, pi over 4 plus 2 and pi. Square root of 2 to the power 4 is just basically 4. Try solving it yourself. If you don't know how, tell me so I can explain it to you. Get the 4 inside the brackets. E to the power I pi plus 8 and pi. Now change it to the polar form, or not the polar form, the cosine and sine form, the imaginary form. 4 cosine pi plus 8 and pi plus I sine pi plus 8 and pi. Okay, I told you earlier, if you don't have any power here, okay, your solution is almost done. You can just cancel anything that's related to n pi, anything that's similar to 2n pi. As long as it's just even number, 2n pi, 4n pi, 8n pi, whatever, you can just cancel it, because that's also equal to 0. So you'll have 4 cosine pi plus I sine pi. Okay. Cosine pi is equal to what?
-1.
Minus 1. And I sine pi is equal to what?
0 0.
0. So just bring the 4 inside. You'll get -4 plus 0i, or just -4. So this whole term can be evaluated using this method, which is equal to -4. You can see it's very similar to the last problem, but just it's much easier, but it's totally different. You cannot use this method over that. I will send you this folder and you can check my summary. There's a similar question for this. Okay, I got you back on some concepts in complex. I will give you some weird questions that I got in my final. In my final, we didn't get any straightforward questions. We got some weird looking questions. We got this drawing, the weight of someone hanging from these two ropes. It was actually called the trampoline problem. Trampoline problem. Okay, we got T1, T2, and we got angles. Let's say this 45, and we got this one here, also 45. So how are you going to solve this one? This will be similar to the stuff that you studied in Physics 1 and statics, but you will use the skills that you got from analytical methods. Okay, the first step is to change the angles from degrees to radians. And as for this one, you need to measure the angle from the reference. This is called the reference. You need to measure it from here. You know how to do this. It's just a summation. You have here 90 degrees. You have 45, 90 plus 45 is equal to 135. Okay. The 45 degrees multiplied by pi over 80 to change it to radians, you will get pi over 4. As for 135, pi over 180, you will get, I'm not sure. Does anyone know? I think it's 7 over 10. 7 pi over 10, I think. Yes. Okay. Do you guys understand this?
Why did we multiply by pi over 180?
To change it to radians. If you are given a degree, if you're given the angle in degree, you need to change it to radians.
All right, thank you.
Okay. Just make sure of this value. Can you calculate it for me? You'll be given an easier value.
3 pi over 4.
What?
3 pi over 4.
3 pi over 4, which is okay, close to this. Okay, 3 pi over 4. Who's that, Hassan?
نعم.
Okay, I'll tell Dr. Shabi about you. Okay. So, okay, now you need to find the values of each tension force, T1, and you'll have T2, and you have W. T1 is basically the magnitude of T1, open a bracket, cosine. You will use this angle, the new founded angle, which is 3 pi over 4. 3 pi over 4. You don't need to use the 2n pi here because it's useless. Plus I sine 3 pi over 4. As for T2, the same thing. Cosine pi over 4 plus I sine pi over 4. As for W, the magnitude of W, cosine. Do you know what angle is this? Do you know what angle is this? You can count them. You have a 0 here, pi over 2, pi, 3 pi over 2. Okay, we'll get 3 pi over 2 plus I sine 3 pi over 2. Now you need to simplify them. Use the table that Dr. Ashabi gave you. 3 pi over 2, where is it? Okay, 3 pi over 4, you'll get T1. Cosine 3 pi over 4 is equal to -1 over square root of 2 plus sine. It's going to be the same, right? Sine 3 pi over 2 is just 1 over 2 I. Okay, that's for the sine term. As for T2, pi over 4 is going to be 1 over square root of 2 plus sine, which is also the same thing, 1 over square root of 2i. As for W, which is interesting, calculate 3 pi over 2, cosine 3 pi over 2 will be 0. As for I, sine 3 pi over 2 will be negative I, or negative 1. This can be simplified W negative I. Okay. Now looking back to the diagram, you will see that these values actually make sense. Okay. Using your skills that you studied from statics, you can see here that this force is going to the left, which is indicated by this sign. And you have this force that's going upwards and rightwards, which is also indicated by its positive signs. As for W, that doesn't have any horizontal components, which is 0 in here, and only have one vertical component, which is heading downwards, which is also indicated here by I and negative. Okay, this question has a new idea, and applying your old skills and your new skills to solve the similar problems. So okay, let's say that T1 and T2 and W are given, and in the question that you were asked to find the total force, or the total force, yes. Let's say that these values are given in the following order. Let's say 3 kilonewtons, 2 kilonewtons, and you have here 1 kilonewton. You need to apply them here, and just simply find the summation. So the total force will be equal to T1 plus T2 plus W. You don't have to use different weird components. Just evaluate these values here. Put these values here, and you'll get a final answer. And just simplify it, and you'll get an answer in both R plus I J omega or something. You'll get it in this form. Try solving it yourself and send me the answer in WhatsApp after the tutorial finishes. Okay, do you have any other question over a complex topic or something? Do you have anything?
Yes, can you check the WhatsApp group, please?
Just a minute. You sent nothing.
It's the square root of negative 16.
You need it? Square root of negative 16 is equal to square root of negative 4 times 4, which is square root of negative 1 times 4 times 4. I'm just over explaining it. It's much easier. You can just solve it by looking at it. Square root of negative 1, square root of 4, square root of 4. Square root of negative 1 is equal to what? What do you think it is? Guys,
It's 3.
I. What's 3? I. Okay. Times 2 times 2, which is 4i. Just by looking at this, you can find that it's 4i without just using this whole solution. Did the doctor ask you about this question?
No, but it was in the previous exams that I mean the practice questions the doctor sent us.
Doctor is sending you some easy questions. You'll not have these questions in the exam. I assure you that. See, guys, the thing is with Dr. Shabi, he will not give you straightforward questions. He'll give you some new idea questions and for you to just think about it. You'll not just find the answer in the question.
بشر اليوم كلمت الدكتور أنا.
Yes.
He told me he's gonna bring like straightforward questions.
Who said that? The doctor?
I told it to the doctor. He said it's very easy. I think you know the questions you sent in the group as PDF.
Yeah.
I think he's gonna bring something similar because in robotics that's how we brought the questions, like straightforward, no calculation. Because it's much.
I sent you questions. I sent you some questions before, but which one?
Yeah, like the one, like the question where it asks you if the function is odd or even.
Yeah.
I think he's gonna bring something like similar to that.
You can see that the first question I sent you with the weird signal. He gave a similar question in the midterm, and you can say that most of the class got it wrong. So try solving it yourself. It doesn't need solving. You just see where the interval is just mimicking itself. This is the interval. There's nothing to solve here.
Can we solve questions similar to the ones you posted on WhatsApp?
Okay, the tension question is similar. Okay, I will start with the question 1 with the weird signal. You will see that you have a certain signal. It's just mimicking itself. Okay. Trying to do something similar. I don't know how to do it. Okay. Okay. Let's say it's just the same. You have a pi, you have 2 pi, you have 3 pi, you have a 0. So what's the interval? What's the interval of this signal? 0 to pi, that's it. The length of the interval is pi. There's nothing to solve here.
Beshr, can you go to the previous question?
Which one? Which one?
Not the last one.
This?
No.
This?
Go back.
This?
لا بعد ورا. اوكي هني. شفت
This is Sultan.
شفت الايكويشن اللي E باور theta J plus J. هاي متى استخدمها أنا؟
Which one? This?
إيه.
Always.
يعني هاي مال magnitude ولا مال شو بالضبط؟
Most of the time. You're using this equation to transform this one to its polar form.
Okay.
Okay. Do you have any other question on complex? I'll give you a question of mine. Let's say that you're given that y is equal to 4 minus 3i and x is equal to 4 minus... Yes.
I have one more question. When
What
time
is
I
it?
write 2 by n and I add it with the pi?
Always. Most of the times.
How most of the time and how I know from the question?
Okay. In straightforward questions like this one, no, not this one. Like in this question, some simple question from the ones that Dr. Shabi always explain on, you'll always use 2n pi and you just evaluate it to the end. And look, when you reach this point, you will check if it's a fraction. Is it n pi or just a fraction, 1/3, let's say 1/3 n pi? You need to keep it, but whenever you have an even number here, 2, 4, 6, 8, 10, 1 million, you can just cancel it. But if you have anything but an even number next to the n pi, anything but to an even number, you need to keep it and you need to solve it using this method. Using this method, when you have n0, n1, n2, n3, till you finally reach to the point that you're just having the same numbers again. Do you understand?
Yes.
I don't
Okay.
think so. Okay. Let's say you're given y and x, and z is equal to y over x. 4 minus 3i over 4 minus 4i. How can you solve this without using your calculator? You will multiply by the conjugate of the denominator. So 4 plus 4i, 4 plus 4i. Simplify it, and you will get, just a minute, you have a shortcut for this. I will give you an equation that's a shortcut for this. I just don't want to. Okay, the shortcut is annoying. Okay. The first thing is that you're going to have 4 square plus 4 square. This is fixed. Whatever the value is here, just keep them here with the summation with the square. As for the denominator. As for the numerator, you need to do, I don't know what it's called. Okay. So 4 multiplied with 4 is 16. 4 multiplied with 4i is plus 16i. Negative 3 multiplied with 4 is negative 12. Negative 3 multiplied with 4i is equal to what? Plus 12. Do you know how to get this? 3i multiplied with 4i. Negative 3 times 4 is equal to negative 12. I times I is equal to negative 1. You'll get a 12. You get this? Okay. So yes, these two will get cancelled, and you will have 16, 16, 32. And you have 16 plus 16i, which is equal to half. This is a plus sign. Half plus half I. Okay? You get this?
Bro, I have a question.
Yes.
Can you go back?
Yes.
So over here, when you multiplied minus 3i with 4, shouldn't it be minus 12i?
Which one? This with this?
Yeah.
Minus.
I mean minus 3i with 4, not with 4i.
Yeah.
So shouldn't it be 12i?
Correct. I actually didn't see that. Okay. So this is nonsense. Okay. I'll just rewrite this again. 16 plus 6.
مش المفروض 4 minus 4j multiplied by 4 plus 4j. Let's remove it.
شو هي؟ Which one?
اللي تحت اللي عندك.
شوف هي.
يعني يوم سوينا multiply. How you get 4 square plus 4 square.
خليها ثابتة. عندك المقام، خذ المقام هاد وهاد خليهم سكوير بس، وشيل الساين خليها بوزيتيف بس. هي fixed. It's a fixed method. Whatever you have here in the denominator, just keep it as it is. Change the sign to positive, always positive. Whatever you have, just change it to positive and square the both numbers. Okay. You will get this. 16 plus 12 is equal to 28. Okay, and 16i minus 12i, negative 4i over 32. You'll get 28 over 32 minus 4 over 32i. You can simplify this more. You'll get 28 over 32. 28 is equal to just a minute, let me check this. 28 over 32. No, you cannot simplify 28 over 32 to keep it the same. 4 over 32 is 1 over 8i. Okay, you can check this. The thing is, it's just a plus bi similar to this one, C plus DI. Just need to do this normal multiplication. Okay, what else? What do you have? If you're asked to find, if you're given y is equal to 3i, or no, 3 plus 3i, and you're asked to find this, if you're giving this term, what would you do? Do you know what this term mean when you have these two brackets?
The magnitude.
Absolute value.
Magnitude, not absolute value. Exactly, magnitude. We had this question before in the quiz, and many people just find the absolute value, which is incorrect. You need to do 3 square, which is 9 to square root of 18. That's the magnitude.
By the way, Beshr, when will we start doing Fourier?
Fourier. After this question, do you have any other question regarding complex? Do you have any other question regarding complex? Okay, first thing I want to know from you guys, did Dr. Shabi tell you anything that's not included?
في
It's
سؤال
complex for
not included.
what?
في سؤال مش not included. بس أحد من الشباب يقدرش الحين.
شو هو؟
اللي هو آخر سؤال اللي هو مال كومبلكس اللي بعت لك إياه.
حسن بعته أو شيء؟
أنا بعت لك إياه، قلت لك.
وين؟
على جروب.
هذا المداخل؟
قلت لي عليه سهل. هذا سهل.
هو هذا أحسن واحد لكم للحل أصلا.
بس إنه هذا حلينا عليه سؤال آخر شيء، وكل حد قال صعب. بعدين قال
It's easy, but the Dr. Shabi just likes to, how do you say this, to give you more. Okay, you can solve it in an easier way, but it's fine. We can go by what you want. Okay, we have this question. The first thing that you want to know is how to determine if this function is given as an odd, neither, or even. Do you know how to do that? Odd, even, neither. Yes, you need to draw a graph. Yes. And most of the times, you'll be given to find the answers for an either function. This is a good example of an either function. Zero, pi, negative pi. Okay. And given that f of x, okay, this is the x and this is y of x. In some questions, you will get y of t and t. It's the same. Okay, because Fourier series is mainly used in time domain. So don't worry about it. You're given 0 and x, negative pi, x, 0, 0, x, pi. Okay. All you need to do is to find a of 0, an, and bn. You need to use 3 formulas for each one of them. The a of 0, before finding them, actually, you need to find L, the length. You'll find this term and this term. You get pi minus this term, which is minus pi over 2, which is 2 pi over 2, which is pi. Okay. Now you need to use this term 1 over L, negative L to L, f of x dx. Is there anything? These are the question in the PowerPoint he uploaded. Someone sent this. Okay. Too many questions to solve. I see nothing. Okay, these are just similar to the ones that we solved here. Okay, you can use the test bank that and this is Hana Yusuf. Okay, you can use the test bank that she sent here on the group and use the question that I will send you after the session and try solving as much as possible. Okay, 1 over L negative L to L will be equal this function and this 1 over pi, open a bracket, negative pi to 0, 0 dx plus plus 0 to pi x dx. You'll get 1 over pi 0 to pi x dx, 1 over pi x squared over 2 pi and 0, 1 over pi square over 2 minus 0, which is equal to pi over 2. That's A0. An is equal to 1 over L, the same interval, same everything, but instead of f of x, you'll get 1 of negative L to L, f of x, cosine n pi x over L dx. 1 over L, this one will be cancelled, so you just have this term, negative pi, sorry, not negative pi, 0 to pi x cosine n pi x over pi dx. The 2 pi's will get cancelled. You'll get 1 over pi 0 to pi x cosine nx dx. Okay. Do you know how to solve this?
Bro, just one question. So integration of 0 is just 0, right?
Yes, if you have an integration of 0 without any intervals, you'll get c. But if you have any intervals here, 0, 1, or whatever, you'll get a 0.
All right, thank you.
Anytime. Okay. Do you know how to integrate this? You can integrate it in 2 methods. The first method is called integration by part, uv vdu, which I don't like. You can use the tabular form, which is x 1 0 cosine nx. The integration of cosine nx is sine nx over n, and the integration of this term is negative cosine nx over n squared. So you have this plus and minus, and you will get this 1 over pi 1 over pi x sine nx over n plus cosine nx over n squared, 0 and pi, the intervals. 1 over pi sine n pi over n plus cosine n pi over n minus 0, because if you substitute 0 with the x, everything will get cancelled. Okay, and cosine nx becomes plus cosine 0 over n squared. Okay, now you need to simplify this. Do you know how to simplify this? You'll have 1 over pi, open a bracket, sine n pi is simply 0. Cosine n pi, this is an interesting shortcut to use. Cosine n pi is equal to -1 over n. For you to, to have it in an easier way, instead of imagining the pi and how it affects the cosine, you can simply use this one, this term. It's much easier for you. So you'll get -1 over to the power n over n minus 1 over n squared. Is this correct? Just a minute, please. Sorry, this is an n squared here. Okay. Okay. It's the same 1 over pi, -1 the power n, -1 over n squared. Okay. To solve this correctly, you need to take the n square outside, keep it with the pi, and -1 n minus 1. Okay. Now you need to test the value of this of this n, that's an. Okay, you need to use an odd n and even one. You need to test these two values in this side of the equation. Don't use it here. You'll not need to use it. Okay, so you'll have, let's say n is equal to 1. I usually choose 1 because it's easy. 1 pi n squared, keep this n and change the others. -1 to the power 1, -1. This will give you -2 over pi n squared. Okay, so when n is odd, an is equal to -2 pi n squared. When n is even, use 2, 1 pi n squared, -1 minus 1. -1 squared is basically 1. Is 1. 1 minus 1 is 0. So when n is even, it will be equal to 0. When n is odd, it's -2 pi n squared. Write this aside. An is equal to -2 pi n squared n odd. Okay. Now use Bn. Bn is -L to L, 1 over L. 1 over L, -L to L, and you have the original function times sine n pi x over L dx. You will check here that the 0 term will not be integrated, so we'll just integrate the x. 1 over L, which is 1 over pi, and 0 to pi, x sine n pi x over pi. Pi and pi will get cancelled. 1 over pi, 0 to pi, x sine n nx dx. Now you need to integrate it in the similar way that we did in the an. x1 0 sine nx. The integration of sine nx is negative cosine nx over n, negative sine nx over n squared. Positive and negative, 1 over pi, 0 to pi. Sorry, there's no integration here. Okay. X cosine nx over n minus positive sine nx over n squared. Okay, 0 to pi. Evaluate these. 1 over pi, negative pi, cosine n pi over n plus sine n pi over n.
Doctor, n squared.
N squared, I always forget this. Okay. Now as for the 0 term, 0 plus sine 0 over n squared. Now simplify this. What do you have here? Sine n pi 0. Sine 0 is 0. So what you get? 1 over pi negative pi cosine n pi over n. The pi's will get cancelled and you can get 1 over n. The pi's will get cancelled and you have the n, and cosine n pi can be simplified to negative 1 to the power n over n. Now you need to test n for odd and n for even. N is equal to 1. Negative 1 to the power 1 is n. There's a negative here I forgot about. Okay. Negative 1 to the power 1 over n, just 1 over n. N for even, you will get negative 1 squared over n, which is negative 1 over n. See here in this question, we have a special case that even if we used the n and the odd values, we'll still have two different values. Usually in most cases, in most of your questions, you'll get either one of them is equal to 0. Okay? So what you will do next, we have the an, and we have the a0, and we have the bn. As for the bn, which one for you to use? You need to use this one, the original one. This is the correct way to use it. Now, substitute it in the Fourier series. You'll get a0 over 2 plus summation bn sine n pi x over L plus summation an cosine n pi x over L. That's f of x. That's x approximation. Okay. A of 0 over 2. We have pi over 2 over 2, which is what? Over 4 plus summation n negative here n over n sine n pi, not n pi, nx plus summation n is odd. I prefer that you write it this way in the exam, and here infinity, and the an, which was negative 2 pi n squared cosine nx. Okay, this is the final solution. Do you understand what I did here, guys? Hello.
Yes.
Okay. What other questions you have?
By the way, I have a question.
I have a question.
Yes. So say it first, please.
Okay, so bro, before The thing is that the questions are multiple choice. So like, is there like a shortcut to figure out like how to eliminate some options and figure out a faster way to solve it without solving as much?
See, in some cases, I think that he did this in our exam. He gave us like, what's Bn for sine x? Or not a Bn, let's say An for sine x. Sine x is an odd function. And odd doesn't have an An. So An is equal to 0.
Makes sense. And I just want to confirm, odd ones are like, for example, at pi and minus pi. Pi, let's say it's 1, minus pi, it's minus 1, so it's odd. But if it's even, they both have the same values.
I didn't get what you said.
I mean, like, a sine function, it's odd because at one point it's positive, and at the same point in the negative area, it's a
Yes.
negative answer. But even
Yes.
on either side, they're going to be the same, like x squared.
It doesn't have to do with anything with the x squared.
I'm
Let's
just
say you
saying
have a
x squared, like, I'm giving an example. A graph of x squared on the positive side, negative side is going to be the same value.
okay.
So it's even, right?
Yes, x squared cosine x, many other function cosine x, x to the power 4, anything to the power of an even function. These are all considered even functions. When you have a function that you can see is the same from the both sides, these are identical, symmetrical. This is called an even function. When you have a function that's anti-symmetrical, that's called an odd function. But when you have a function, for example, the one that we solved in this look, where the right side is completely irrelevant to the left side, nor to the x-axis reflection, that's called an either function. And when you have an either function, which is most of the time, you need to evaluate using the Fourier series and the long method that we just used. If you have something simple and you can see that it's simply symmetrical or anti-symmetrical, you can just conclude it as fast as you can that one of these values is actually equal to 0. Okay?
All right, thank you.
As for complex, I'm not sure why Dr. Shabi removed this for you. Who said that it was difficult? It's much easier than the normal method. Do you have any specific question that you want me to solve?
Yes. I actually have a question. Okay.
Yes.
So how do you find the functions from a graph? Because the doctor told us that we should know how.
Functions from a graph? Like this?
Yeah, like x
And tell you what's the
squared or
function
x
here?
plus 1.
And told you
yeah.
what, find f of x?
Yes, yes.
Okay. I'll draw a better drawing first. Draw. This is interesting. Why
Will
didn't
we
you
be
use this?
asked to draw the graph during the
I
exam?
don't see with Dr. Shabi, expect everything. Expect the not expected. Okay. Let's say that you're given this function. Okay. You have a 0 here as the center. And you have here, let's say 3 and 3. And you have negative 3. And he asks you to find f of x and L. And what else? I think that's it. And the amplitude, let's say the amplitude. Amplitude. I know that you didn't take it, but expect everything. The amplitude is the what? What?
Amplitude the same as the periodic function?
It's a periodic function, yes. You'll just do the same thing here. is the same from all sides. Okay, but we'll work on this section exactly, specifically, because it's easier. The amplitude is this one. Is 3. That's easy. The L is this one and this one. 3 minus 3 is plus over 2. 6 over 2 is 3. That's L. That's easy. Now what about f of x? You will try to evaluate this function as much as possible to simplify it for you. Looking by here, 0 to 3, you have a fixed line, a straight line. You can use y equal to mx plus b. M is equal to the rise over run 3 over 3 x plus b. You can see here that it's starting from the center. There's no any moving in the signal. So b is equal to 0. And 3 over 3 is equal to 1. So the answer is x. That's the function of y. As for this one, it's clearly a 0. So when you're asked to write the function, it's f of x, 0, x, and write the intervals for each one of them. -3, x, 0, 0, x, 3. That's the whole function. Okay, maybe for slightly different functions, let's say that you're given this function. There must be some values for you to understand that this is a horrible drawing. You're giving this function. I don't think that you'll get it, but you're giving this function. The doctor must give you something for you to know that this function is the one that you're solving. So let's say that this is here is -4 and 4, and this one here is the same height, which is 16. Judging by the values, 4, when can 4 become 16? When it's 4 times 4, or it's 4 squared, meaning that this function is x squared. There are many types of functions that you need to understand. I'm not sure how I'm going to deliver this information for you, but try as much as you can to understand this. I'm not sure that the doctor will give you such questions, because he will focus on the stuff that are related to the course, because this is not really related to the course. But remember that you might need to use previous skills like that, the ones that you use from differentials and calculus. Like using this method, integration by parts or tabular form, you need to remember it from calculus. Check the summary that I sent you. There are some solved questions. Regarding the Fourier series, there's a one tiny mistake, so ignore it. Oh no, there's no mistake. The only mistake is in the complex one. So, okay, you can review it. There are questions on everything, including these. Okay. Do you have any specific question? Any other additional question?
Beshr?
Yes.
سؤال بعد.
Yes. Say it
Beshr,
first, please.
the thing is that like I'm okay with complex, okay, but whenever
Yeah.
I start doing Fourier,
Yeah.
like the moment I see the question, like something happens to me. I can't really figure it out. But like once you know, you told me the integration, the shortcut for integration by parts. Okay, because of that, like okay, I understand something. But like if you don't mind, like once people finish their questions, can you solve like a few more Fourier so like I can actually understand how to do it?
Yes, it's fine.
Thank you.
Someone's asking.
أيوة. بس في اللي هو ال 1 over 2 انترفال هذه مرات تجي في السؤال. شو
1 over 2L.
Yes.
1 over 2L is only used in the complex. You don't need to use it here. Fourier series, complex form. See, it's only in the complex form. Only in the C and only in the CO. You don't need to use it here in these. If you mean this, if you mean this one, 2 over L, this is
2 over L. Sorry.
2 over L, I personally do not advise you to use it. 2 over L is useful only if you're finding the Fourier series of a certain function, not a compound function.
يعني we always use 1 over L. It's better.
Yes, 1 over L is better for you.
Thank you.
Because as you see here, most of your questions are really similar to this form, right? You're
Yes,
given
yes.
2 functions, sometimes 3. But if there are 3, it will be easy because you will only need to use one of them. Anyway, you're given 2 functions here. You need to evaluate it. You need to divide the interval. You can see here a to 0. You get to find the L. Negative L to 0 for G. 0 to L for H. Okay, it's easier for you to use this one. If you use 2 over L, 0 to L, you'll get halves and stuff and be annoying for you to solve it. Okay, you get this one is really easier for you. I don't know why you guys told the doctor to remove it. Much more easier, but no problem. You have anything else? Said, you said you want me to solve for you some questions, additional questions. Do you have a specific question that you want me to solve, Said?
No, not really, but like the thing is that I just like, the problem is like I look at the question and I'm blank. Like I'm like, what should I do?
Your whole exam is going to be MCQ or just some of it? Or?
No, the whole exam is gonna be MCQ. He sent what's it called? He said there's gonna be like 20 questions. Out of the 20, 16 are complex and just like 4 are for Fourier.
Okay, as for the Fourier, will not ask you to do everything, by the way.
Yeah.
Just ask you to do even, odd, stuff like that. Maybe we'll ask you to do a full question, but the others will be much more simpler. Okay, let's say that you're given this function. A unit step function, a normal unit step function. Okay, I can draw it better. Or better, you're given a step function, not unit step function. This is called a step function. And you have it here as in pi, here as a negative pi. You can see that I'm using the interval pi because it's easier to solve. It depends on the doctor's choice in the exam. It doesn't matter to what I choose. Okay. Now you need to find the a of 0 integration 1 over L negative L to L f of x dx. You can see that f of x is a part of 2 functions. Okay. Find L. L is equal to pi minus pi plus over 2 pi over 2 equal to pi. Understood so far? Now you need to use
Yes.
1 over pi, the integration negative pi to 0 for the first function, which is this one. Negative 1 dx and plus 0 to pi 1 dx. Solve it, try solving it. You will get 1 over pi negative x negative pi 0 plus x 0 to pi 1 over pi 0 minus it's going to be messy. Going to be plus or minus? Just a minute. Okay, plus pi minus 0. Plus going to be 0 total.
But won't it be like minus pi, positive pi, pi plus pi, 2 pi?
Just a minute. I really got confused. Just give me a minute, please. It's really confusing. Just a minute. Okay, it's minus pi. Minus pi. It's going to be minus pi. We have 3 minuses, so it's basically minus pi. Minus pi plus pi is equal to 0. It's correct. Okay, Said, you were asking me about the shortcuts.
Yeah,
Correct? Look at this. Look at this.
it's an odd function.
Yes. What does
So
this mean?
A0 and AN is 0.
Yes.
Bn has a value. So we don't need to calculate A0 or AN.
Yes. See, in this question, Dr. Shabi is really nice to you, okay? He'll give you this question, he'll give you this drawing, and will ask you find A0 and AN. And he'll give you 4 different choices. You can see that maybe A0 and AN are equal to whatever. And you see one of the options is AN and A0 are equal to 0. There's this tip about Dr. Shabi when he does his exams. If you don't know how to solve the question and you have in the options a 0, that's probably the answer. I got this from my TA when I was taking analytical before you guys. Okay.
All right.
Do you have any other questions? If you'd like me to continue, I'll continue solving Bn, which is better. So it'll have a value. Okay, 1 over pi integration negative pi to 0 negative sine n pi x over pi dx plus 0 to pi sine n pi x over pi dx. Simplify it. You will get 1 over pi, negative outside, negative pi, 0 sine nx dx plus 0 to pi sine nx dx. Simplify it. 1 over pi. The integration of sine is negative cosine, negative cosine, cosine nx over n. Negative pi and 0 plus negative here, cosine nx over n, 0 to pi. You'll get 1 over pi cosine 0 over n minus cosine n negative n pi, which is the same of negative n pi, because cosine is an even function, so the negative does not affect it, over n minus cosine n pi over n plus cosine 0 over n. Simplifying 1 over pi, cosine 0 over n. What? Someone sending me something on WhatsApp? Okay, there's nothing here. Okay. Cosine 0 over n. What's cosine 0 over n? It's 1 over n minus cosine n pi negative 1 to the power n over n minus the same thing, negative 1 to the power n over n, cosine 0 pi, 0 over n, 1 over n, 1 over pi. Gather everything, you'll see that they all have the same denominator. So you just get to 1 here, n, and gather the similar values. You'll have a 2, negative 2, negative 1 to the power n, which is also equal to 2 over n pi 1 minus negative 1 over n. Now all you need to do is the test. N is equal to 1, n is equal to 2. When n is equal to 1, you'll get 4 over n pi. When n is equal to 2, you'll get a 0. So Bn in odd is equal to 4n pi. Now to write the Fourier series of this function, we know that a of 0 and an are equal. They're equal to 0, and we have Bn. So the Fourier series becomes summation n infinity 4n pi sine nx. Okay, that's the solution of this Fourier series. You understand this, Said?
Yes, Bashir. I understood. Thank you. And there's one other thing that I need help in.
Yes.
It's with the integration. Yani, the integration is a problem for me. So if it's integration of sine and like those things, like if you don't mind, could you send me like some notes for the integration?
Other than the one you have, I think it's here.
In the
Basic concepts. You have these.
uh-huh.
Okay, and you have these here.
Okay.
You basically need the first two only.
Okay.
And that's all you need.
Perfect. All right. Thank you so much.
Welcome. Just a second. I'm checking if there's something missing that we didn't cover. The magnitude, you already know how to find the magnitude. These aren't really coming. These are just some formulas. If you didn't understand how to evaluate, you can use these formulas for you. And you have a solved example here. Okay, this one, I want you to focus on this one. I already explained it. I don't know if you need something more. So try. You know how to draw these. If you're having to find the values of something, do you know how to draw it? Do you know how to draw? Guys, do you know how to draw?
For drawing, like the real goes on the x-axis and the imaginary goes on the y-axis. That's
Yes,
all.
yes. Exactly. That's it, I think, for chapter 2. Chapter 7, we covered probably most of everything. As I said, you need to determine if the function is even, odd, or neither. If you are given a neither function, you need to evaluate the full Fourier series. If you're given an even or an odd, you have these shortcuts, use them. The Bn, An, and A0, and when they're equal to 0 and when they're not. You need to determine if this function is even or odd. Do you need any other question, guys?
Is there a way to know if it's odd or even without having to draw the graph?
It's better for you to draw it. It's better for you to draw it.
Okay.
You know, giving you an analytical solution for this will be tedious and long. You will waste time. So drawing a simple drawing for you to understand is much better for you. You're given this one, f of x. -1 and 1, 0x, 1, 1x2. How can you determine if this is even or odd? By just looking at the function. You need to have a strong imagination. So instead of using your imagination, just draw it. That's it. It'll be easier for you. You don't need to do a full drawing. You can use a simple one here. Just draw it on a side. If you're given, let's say, sine, we know that the sine is an odd function. So 0 to 1, you will get this one. 1 to 2, something like this. You'll get a similar thing. So we'll get this. Is this an even or an odd function? Or an either? First of all, this is not an even function. An even function should be exactly like this one, but in a mirror-wise. Okay? And this is certainly not an odd function because there are any negative values here. There are any negative values. This is not symmetrical nor anti-symmetrical. This is just copying, mimicking. So this is an either. Okay, but when you have this one, let's say you have this function, which is a sine function, or x to the power 4, they're similar at the beginning. You can see here that's an even function. It's symmetrical. Symmetrical and have the same values across. If you give a horizontal line, it will cross in the similar paths, but just in different sides. So this is an even function. If you are given this one, which is a cosine, you can see here that the value, let's say at here, it's a negative value. But if you give the value at here, you can see it's a positive value, although it's the same distance from the 0. Let's say at 1, it's a negative value, but at 1 here, it's a positive value. That's an odd function. An odd function, when you have an f of x, is equal to negative f negative x. You guys, all of you know Dismus, right? Dismus. Graphing calculator. So you're given sine x. You can check here. At sine is equal to negative pi over 2. It's equal to the positive amount, the same amount. You can see it's -1, and here is 1. The difference is the signs. But if I gave you a cosine, you can see here at negative pi over 2, it's the same at pi over 2. So the signs of the x component doesn't affect the y component. If the sign affects the y component and giving it a negative value, that's called an odd function. Okay, here in an even, f of x is equal to f negative x. They're the same across. But in neither, f of x is not equal to f negative x in any form. This is a neither. And this is even, and this is odd. Do you get this?
لحظة Beshr.
Yes.
For the first one, for
Neither?
yeah, for the neither. Shouldn't it be يعني when you substitute any value for x, let's say 1 and -1, wouldn't it give you the same value?
See, this is a matter of, this one here is given in a concept way. If you want to actually evaluate it, it will be tedious for you. How are you going to evaluate this here? It's a step function. How are you planning to do this here?
I would substitute 1 and 1 basically.
Yes, which will give you different functions, right?
Yeah.
Okay, so you cannot apply this theorem here. You can apply it here and here, but this will be in easier functions, like in sine x. Is it even or odd? Cosine x. Is it even or odd? X to the power 4. Is it even or odd? X to the power 3. These are easy to evaluate. Maybe by just simply by your experience, you can understand that this is odd or even. But if you're given a step function, a step function is actually an odd. But if they gave you a unit step function, this one, if you were given a unit step function, get a 0 here, does this look to you symmetrical at any form?
No.
Okay, but what about this? It's an anti-symmetric. This one is anti-symmetric. This is not symmetric nor anti-symmetric.
Okay. So the odd is the one that would be mirrored or the even?
It depends where you're placing the mirror.
On the y-axis, for example.
Yeah. You're having this from here. If you want it to become even, what you will do? You'll do the same from here. If you want it to become odd, you will do this. What about this? This one is called x squared. This one is called x cubed. X cubed is what? Odd. It's famous. And this one is famous to be an even. This is an x squared. You understand the difference here?
Yeah.
Okay, what else you want me to explain? I want you to solve as much as possible. I just got this question in my mind. Given the forces F1, 3 plus 3i, F2, 3 minus 3i, and F3, 4 plus 3i, and F4, 3 minus 4i. I want you to find F total. How are you going to do this? In the most simple way possible. F total is equal to F1 plus F2 plus F3 plus F4. Just find the summation. How are you going to do this? Write these again and find the summation of the real values plus the summation of the imaginary. That's the F total. So let's do it here. The real values are 3, 3. Let's give this a negative sign. Okay, 3, 3, 4, 3 plus 3 plus 4, negative 3, plus, as for the imaginary, 3, negative 3, plus 3, negative 4, I. Simplify this, you'll get 3 plus 4, 7, plus negative I. Okay, that's F total. If you have to draw these and find their summation, you can see that the F total is in the negative axis and the negative y axis, or the negative j omega axis, and the positive real axis, which should be here. The function should be similar to this, and you have a theta. You have a theta here. Okay, now this is the value of in the vector form or in the complex form. What about if you want to make it in magnitude form? You'll need to get 7 squared plus 1 squared, which is the square root of 50. That's R. So the resultant is 50. And as for the angle, tan inverse, the imaginary part is -1 and the positive part is 7. So whatever this value is, you will get it here in radians. Okay. You will not get the same numbers. You will get simpler ones, like maybe -1 and 1. Some easy numbers that you already know, or they're just given in the equation sheet. So whatever number you'll get here, and you can represent it in r theta form, or you can represent it in the polar form, which is r e I theta 2n pi if you want. So you can represent it here in the r e I theta. Do you understand, guys? Do you understand me, guys? Is everyone in the meeting?
Yes, we're here.
Okay, there are 5 attendees. What about the others? Okay,
got
do you have
bored.
any what?
They got bored.
Yeah, they got bored. Tomorrow they will get 5 out of 20 and they will blame me for not giving them correct questions. Okay, do you have any specific questions that you want to solve? Since the complex form of Fourier series is not given, which is unfortunate because it's easier for you, because the complex form of Fourier series helps you to get Bn and C and An in the same Fourier series, and it's much easier. In the same equation, you can get An and Bn. So if you already understand it and you cannot solve using this the normal Fourier series, you can use the complex one. I want to give you this question to solve. I will send you actually a whole page to solve some questions that I made. They're easy based on the stuff that we explained today. I'll send them to you on WhatsApp on the group. And the test bank that our colleague Hannah Yusuf sent earlier on the WhatsApp might be helpful. And use the examples that I use, forces and some relevant stuff to the course. Use them because these can actually come to the exam. I got a similar question to this in my exam and the tension force one. Okay. Do you have any other question, guys? Usaid, Sarah, Anna, Mariam, Hassan. Again, another Mariam. Ahmed who's leaving. Do you have any other questions?
If we have a question, we can text you on WhatsApp. صح?
Yes, inshallah. Yes, I will answer you. So that's it.
Basically.
In what chapter you are now?
We did not start anything new yet.
I think that your next chapter should be chapter 9.